Hey everybody, Lars here. It's time for our second review video for Unit 5 on object-oriented programming. I'm actually shooting this Tuesday evening, your last night for Unit 4. I'm not on the futon, I'm in my regular place, so I'm hoping my leg will hold out down here on the floor for the next 20 minutes. Today is post-op day 5. It's been pretty good. I think I'm in good shape. I've got the knee crutch coming. The iWalk 2.0 is being delivered to the house on Thursday, so hopefully I'll be able to put that on and walk around a little bit. I've been getting some reading done. I got this great book, Narconomics, How to Run a Drug Cartel, which is actually a book by a guy named Tom Wainwright. Did I get that right? Yeah, Tom Wainwright. He used to write for The Economist, and he looks at the drug industry as an economist would, and it's actually very interesting, and it's 10 separate chapters on 10 different topics, and it's a really, really good book. I should probably finish it tonight. I don't know. Still doing my email, still trying to do my job as best I can, even though I can't get on campus, so I do all of that stuff. But enough of that nonsense. Right now, I want to go through the middle part of Unit 5, and that has to do with two things that come along for the ride when we create programs using object-oriented programming, and that's inheritance and polymorphism. And they both sound complicated and serious and scary, and they're nothing of the kind. So what I did was I quick whipped up some code for us to look at, and we're going to look at this, and I'm going to explain it and run it, and then we're going to add something to it. And as I add something to it, we are going to discover things about inheritance and polymorphism all at the same time. So just as a review, let me first run this code. There we go. Look at that. And then I'm going to put it next to it. And then, actually, let me move this up. And then we can talk about it. For now, we have everything up on the same screen, so we should be in pretty good shape. If you see me fidgeting around, it's because of my leg. All right, a class, kind of like a function, when we first define it and put it in our code, it's just being read into memory. It's not really being used. So the first thing this program does is actually down here. I get a variable called f, and I make it equal to animal. So I want to take the class animal and get an object. And what am I going to give it? I'm going to give it a name, and I'm going to give it a weight, because those are the two things that animal takes in its constructor. And we're going to go through this. I'm just doing this really quick to show you what happens when I run it. So I create an object using the class animal. I give it the name Fred and the weight 75. And then I print f.getName, which is a method up here. So I print the name, and that's what happens, Fred. So what exactly is happening when we do this? This is what's going on. I say f equals animal. So Python says, okay, I'm creating an object with a class called animal. Let me go up here to the class animal and let me run my constructor, because that's the method I run when I create an object. I have two parameters, Fred, string literal actually, and number 75, which is going to be the weight. So up here in the constructor, I have self, which refers to itself. In this case, that's f, okay? Because that's the name of the variable, or that's the pointer that's pointing to the actual object. So while you don't have to put that in there, it's implicit, this is an f. Name is the string Fred, weight is 75. So I come down to this line, I say self.name, the instance variable that only this object is going to have is equal to Fred, because that's what the variable was, and then self.weight equal to weight, which is what 75 was. So now I've created an object that is called f, and in f I have two variables. One is name, and that's equal to Fred, the string Fred, and one is weight, and that's equal to 75. So now I've created my object. In this one line, I have a variable f which points towards an object which has two variables in it. Now, next line, print f.getName. So the first thing Python does is say, okay, what is f? F is a, hold on, I'm going to try to put my leg up a little bit. What is f? F is a object. What is it an object of? The animal class. So I go to the animal class. I'm looking for a method. What method am I looking for? It's called getName. Do I see it? Yes, I do. It's the second one here. So, get name self. What do? Return self.name. For the variable f, the name is Fred. So I return Fred. And that's why I print Fred right up there. Okay? Now, I also have I have a getter and a setter for each of my variables. So I can get name, I can get weight, I can also reset it and make it a different name if I want. If I want, I can come down here and say f.setName and call him Donnie. All right? Then if I print f.getName, it's going to say Donnie because I changed it. All right? But I'm not going to leave that. I'm going to leave him Fred for the time being. All right? Now there's one last thing I have down here. I can now make my animal speak. And the way I do that is I run a method called speak. And right now, it just prints the word sound because it's an animal and I don't really know what kind of sound the animal makes. We're going to speak to that in just a second. Because let's say I want to create an object that resembles a cat. Now, I already have all of this stuff already pre-written for animals. It'd be nice if when I wrote my cat class, I could just use all of this stuff. Well, it turns out that you can, and this is what the first part of the video is about. I'm going to create a class called cat, but I want to tell Python to use animal when I do so. All right? When I use another class as a base for a new class that I'm going to write, it's called inheritance. I am inheriting from the animal class all that it does. Okay? So the first thing I'm going to do is the first thing you always do when you create a class is I'm going to define its constructor. Now, when I do that, I am going to, and you're going to see there's a slight difference. I'm going to ask for all the same things that I asked for when I asked for animal, because as you'll see, I got to go get an animal first. But then I'm going to ask for something a little extra called color. And I'm going to show you how we extend that. Now, I'm inheriting from animal. So really, what I'm doing here is I'm going to create an animal object, and then I'm going to create the cat object around it. Okay? Think of Russian dolls. Think of like putting things on Mr. Potato Head. I already have that base, which is going to be an animal object, and then I'm going to build cat stuff around it. But I need to set up that animal object correctly. So in the first line of the cat constructor, I'm going to call the constructor of animal. Okay? I'll explain this in a moment. Just like that. Okay? Now there's one little nuance here that you probably noticed. And you're going to say, hey, you're calling a method and you're saying self. In this case, I want to do that. Okay? Most of the times I just use self when I define my methods. Now, when I call a constructor of what we call a superclass, or a class I'm inheriting from, I do want to put self in there. Because I'm actually a cat calling on an animal object to be made for me. So I want to let animal know, hey, I'm a, subclass asking for a parent object. It sounds a little weird right now, but you'll get used to it. So the first thing I want to do when I create my cat class is I want to go call the constructor for animal and get myself an animal object that I can build around. Now, you'll notice that I misspelled a knit. Good thing I saw that there. I still have one more thing I haven't taken care of yet. And when I did my cat, I asked for a color, and I didn't take care of it yet. So what I'm going to do is just like any other instance variable. I'm just going to treat it like any other instance variable, and boom, and then I'm done, okay? Now, because I've introduced a new variable, I want to make sure I have getters and setters for it. So get color, self, return self.color. Done. Be nice if it had the proper syntax. How's that grab you? Righty Rudy. I think we're doing good there. Then I want to do def set color self, which would take a variable color, and then I would do self dot color equals color. Nice. And then I'm going to do one last thing, and it's going to help us transition from inheritance into polymorphism. I'm going to define the speak method. But why do we keep hitting that without that? What I'm going to do is, because I know I have a cat now, I'm going to say meow. Okay? And just like that, I have a cat class that uses animal. So what we're going to find out when we use it is that all the things up here, get name, get weight, set weight, can be used by cat because I've inherited animal. So I'll be able to do all those things, and you'll see. I'll show you that. As a matter of fact, I'm going to show you right now. Like I said a little bit last video, and especially this video, we are now too complex, people. We have gotten to the point where you've done a lot in the last 5 weeks, let's put it that way. So now we can't keep everything on the screen. What I'm going to do is I am going to create my variable f. I'm not going to call it f again. I'm going to call it cat. Nah, I don't want to do that either because the class is called cat. I will say the cat equals cat, and I will call him Felix. And Felix will be 15 pounds. That's a pretty hefty cat, to be honest. And Felix will be orange. Okay? So I'm calling cat, giving him the name Felix, 15, and orange. Then what am I going to say? I'm going to say print cat.getName, print cat.getWeight, and we're going to trace through all this code so you know exactly what's going on. And then I'm going to say print cat.getColor, and then I'm going to say the cat.speak. Okay, now when I run this, let's see what we get. Alright, we actually get everything I needed. So now I've got my run and I've got my code next to it, and we are going to trace through all of this code so you know exactly what's going on, and we can go through everything and understand about inheritance, and in the middle of it we're going to talk about polymorphism. First thing I do is I get a variable called the cat, and I say I want to get an object. Let's use the class cat. I'm going to give you Felix as a string. I'm going to give you the integer 15, and I'm going to give you orange as a string. Okay? So what does Python do? Python says, all right, I got a variable. It's saying go use this class. Do I have a class called cat? Yes, I do. Is cat inheriting from anything? Yes, it is. Animal. Does animal exist? Yes, it does. I got class animal right up there. So Python says, okay, we're good to go. Let's find this cat constructor. Do I have a dunder and init dunder? Yes, I do. Self is the variable that was called, so it's called the cat. Okay. Name, string Felix, weight, 15, color, orange. I'm good to go. What's the next line? Animal.init. Now, it's weird to see the way that is named, but I'm basically telling it I want to go run the constructor for the animal object. And because I've inherited from it, I have access to it. So I am going to go up. Self is going to be the cat because it's cat variable. We want to make sure it knows that when it gets up there. Name, Felix, weight, 15. Let's go up here. Boom, boom. We're going to run the init for animal. Self, the cat, name, Felix, weight, 15. So the variable self.name is Felix. Self.weight is 15. Done. I now have an animal object, which I now have down here, And with that animal object, I'm now going to add self.color equals color. What was color? Orange. All right? So I have an animal object with two variables in it, and outside I have a cat object with the color. All right? So all of that got done with that one line. So when I called cat, I now have a cat object, and in that cat object, I have an animal object that has Felix and 15, and my cat object keeps orange. Now really the program sees it that way, but you're going to think of it all as one object. Okay? I have a cat object, he's got a name, he's got a weight, and he's got a color. All right? So, second line, what do? Print the cat.getName. Print the cat.getName. Okay, my variable the cat. What kind of object is that? It is a cat object. So let's look at cat. Do I have a method called getName? Init, getColor, setColorSpeak? No, I do not. Now you'd usually be in trouble, except when you run out of all of these, Python says to itself, okay, did cat inherit from anything? And in this case, yes, it did. It inherited from animal. So let's go up here. Starting at the beginning of the animal class, do I now have a method called getName? Let's see, init, second one, getName. Got it. Return self.name. Self.name in this instance is Felix. So I return the string Felix. I return the string Felix here with the getName, and that's what I print, Felix. Okay? Same thing with getWeight. The cat is what? A cat class. So I look here. Is there a method called getWeight? There is not. Did I inherit from anything? I did. I inherited from animal. So let's go up to animal. Is there a method called getWeight? Init, getName, setName, getWeight. Yes, there is. GetWeight. Return self.weight. The self.weight variable is set to what? 15. So I return a 15. I return a 15 here to the print, and that's what gets printed, 15. Now, to show you some contrast from that, I print the cat.getColor. So the cat is what? It's a cat object. So I go up to cat. Is there a method called getColor? Yes, there is. So this time we don't exhaust it. This time we find it in the cat class. So I return self.color. In this case, what is it? It's orange. So boom, I do orange, and I print that up. Now, the next one is where we get into a facet of object-oriented programming that we call polymorphism. Now, it sounds highfalutin and technical, but it's not. If you break the word down, poly means many, and morph could mean form or change. In this case, we kind of mean it in the context of forms. So that polymorphism means things that take on many forms. In our case, we have two classes, an animal class and a cat class. And the cat class has inherited from animal. But animal, at its base, has a method called speak. And because animal is kind of generic, we don't know what kind of animal, I just put print sound there. So it's kind of vague, it's kind of general, it's not specific at all. When I inherit from animal, and I have my cat class, I know now I'm a cat. So when I speak, I'm going to say meow, or I'm going to say purr. You know, if it were a dog class, a dog would say woof or bark, a cow would say moo, and so on and so forth. So what I want to do is I want to rewrite that speak method so that, similar to the way we did it before with getName and getWeight, when I say to run something, it's going to look in cat first. Now, if I make sure there's a speak here, then it'll get called and you'll never get to that second speak that's in the animal. Okay? Now, if there were no set speak here, and I asked for a speak, well, it would go to animal and run this one down here. But I don't want that, because I know I have a cat, and I know a cat says meow. I'm going to rewrite speak, and I'm going to make sure it says print meow. Okay? So, this is where polymorphism comes into play. If you have multiple classes, and they all have the same name for a certain method, but that method returns different results depending on the context or depending on the kind of object you have, that's called polymorphism. That's many different forms, but it's doing the same thing. So depending on the context, if I tell my dog object to speak, it'll say woof. If I tell the cow to speak, it'll say moo. If I tell the cat, it'll say meow. But they've all just got the same speak method defined differently. We're going to get more into it in the next video that I shoot when we talk about overriding things next week. But another way to talk about polymorphism is with something called overloading. I'll tell you what overloading is next video, and I'll also tell you that Python does not support it. But that's okay, because we have other ways to kind of do what overloading does, and we'll talk about that when we get into the next video. Because the next video, we're going to deal with class variables and overriding versus overloading and deconstructors, and we're going to touch a lot of other, you know, little nicky-nack side things when it comes to object orientation. The big guns right now are you learning about classes and learning a little bit about inheritance and a little bit about polymorphism. Okay, so that's kind of what we're talking about when we're talking about polymorphism, is that we have two methods here. They both have the same name, but they do different things depending on their context. One is just a regular generic animal, and one is a cat, so it's going to say meow. Truth be told, something generic like animal is usually what programmers would call an abstract class, and that it's not really meant to be instantiated. It's always meant to be inherited and built upon, almost like using it as a blueprint, so that when I do inherit from animal, I know, hey, I've got to write my own speak method. I should write my own methods for a bunch of other different actions. You could use the getters and the setters all day long. Abstract classes are great for that. But as far as methods that actually do things, usually you have to write over them to have them perform their own individual functionalities. Okay? So that's pretty much it, and that's pretty much where I'm going to sit on this video. I'm going to let you soak this in. As always, this code, animals.py, is going to be in your resource folder for you to take out and play with and to use and to have around. And if for nothing else, object orientation is something that it really helps to see a whole bunch of examples. So now you have the die class, you have the student record class from the Zell readings and the slides, you have the bank account class from the last video we did, and now you have the animal class, and you have the cat class that it inherits from. And you're going to see really fast next time we do a video, we're going to create a dog class, and we're going to whip it up super fast. And then you're going to find out that these classes, just like functions, can be put in libraries. As a matter of fact, you'll find a lot of libraries in Python these days are just full of classes with different classes of items we can use that have their data and their methods tied together so that you can create objects and then use these different objects. But I think even at the very end of the next video, we're just going to take all this junk, boom, we're going to put it in a library so that all you have to do is import, just like you would import from a library, from a third-party library or from math or statistics or anything like that. You're going to import these different classes in, and then you can use them to create objects and start running your programs, all right? But I don't want to get too ahead of ourselves. For today, we just want to worry about inheritance and polymorphism. And if you look at the example we just did, cat inherits from animal, and then we use it down there. And polymorphism, many forms, is when you have two things that have the same name, but they perform different actions depending on their context. Okay? All right. Good to go. Like I said, I'm going to put this online. Announcements. I'm not going to drive you nuts. I'm trying to front load all your resources, obviously, so you have a lot of time to work on all of these different things. Like I said, I'm shooting this Tuesday night, so it's kind of the end of Unit 4, so you're all working on your quizzes right now, and you're all doing the assignments, and you're all doing your forum posts, so Unit 4 has ended up for you that way. I guess you're going to be getting this so I could remind you that Sunday, not Friday, but Sunday is when you have to hand in the first part of the final project, the proposal. I already see people on the forums talking about that, so that's a good sign, and it looks like you guys are getting your stuff together. So that's really cool. Do not forget, Monday is class. I have gone on to Amazon. Do I have it up? No, I don't. Hold on, let me see if I can find a picture real quick. Is that a picture? I guess that's a good enough picture. Ta-da! I am now going to receive one of these guys, an iWalk 2.0 on Thursday, that I will hopefully then be able to assemble and use to walk around. So knock wood, if this thing works as good as advertised, I will be, yes, medical supply. Hopefully I will be walking around on one of these in the next couple of days. So I will be there, bright-eyed and bushy-tailed, on Monday for our class. I have to get those slides prepared over the weekend, all right? So make sure that is in your calendar. I'm going to be going over the homework assignment from Unit 3. So we're going to be talking about harsh ads and cleaning data and ISIETE and all of those kind of things, okay? So we get everything square as far as homework assignment 3 was concerned. Other than that, keep chugging along. I mean, we've only got about a month left, and in that month we have to cover object orientation, a little bit of data structures, and do your final project, but it's all going to work, and we're all going to be good, and everything's going to be all right, okay? All right, then I'm getting out of here. Look for the next video in the next couple of days. I'll probably shoot it tomorrow. And we'll get you all the resources for Unit 5, and we'll get you all squared away with object-oriented programming, all right? All right, then you be good, and have a good night. I'll talk to you later. Bye.